A current is I is passed through a silver strip of width d and area of cross section A. The number of free electrons per unit volume is n. Find the drift velocity of the electrons. If a magnetic field B exists in the region as shown in the figure given below, what is the average magnetic force on the free electrons? The next part is, due to the magnetic force, the free electrons gets accumulated on one side of the conductor along its length. This produces a transverse electric field in the conductor which opposes the magnetic force on the electrons. Find the magnitude of the electric field which will stop further accumulation of electrons. And the next part is, what will be the potential difference developed across the width of the conductor due to the electron accumulation? The appearance of a transverse EMF when the current carrying wire is placed in the magnetic field is regarded as Hall effect. So we are reading with about Hall effect over here. So this can be treated as a paragraph on Hall effect. So if we start approaching this problem, so the first thing which we say, that if a wire is carrying a current I having the charge per unit volume, that is free electrons per unit volume, or carrier charge density as small n, cross sectional area A, and we already know the electronic charge. So from the equation that is I is equal to Q N A V, or we can write it as NEAV, we can calculate the value of drift velocity, that is the drift velocity is equal to I upon NEA. So this is going to be the answer for first part. So the expression, this expression is obtained in the current electricity chapter, and then from there we are obtaining the value of drift velocity which is equal to I upon NEA. Now the question is asking what is the magnetic force which is acting on it. So if we calculate the value of magnetic force on the electron, so we can say that the force on a charged particle can be written as F vector is equal to E V cross B. Now since it is an electron, so we are putting a negative sign over here. So if we calculate this force, so we can write it as E, the value of V which is equal to I upon NEA, and B. So we cancel this out and we obtain the value of force as IB upon NA. So if we look at the direction, so let us look at the direction in which this force is acting. So since the the current is going from left to right, so I can say that the electron is moving from left to right, something like this, and electron is negatively charged particle. Now the magnetic field is present perpendicularly inward, that is directed into the plane of the screen, and this is the velocity v. So if we calculate the direction for v cross b, then it will be in the downward direction. Now since the direction of force will also depend upon the nature of charge, which is negative charge, so when we do v cross b, we obtain the direction in the downward direction. But since the charge is that of an electron, which is a negative charge, so I say that the electron will move upward. So I write over here upward. So this is how we deal with it. There is also one more possibility by which you can do it. You can directly use Fleming's left hand rule, and using Fleming's left hand rule we can consider it this way, that your index finger is pointing into the plane of the screen, the middle finger is pointing towards the direction of current, that is towards the right, and you will find that your thumb is pointing in the upward direction. So the direction of force is again in the upward direction. So as a result of which this force IB upon NA is directed in the upward direction. Now the next part, the question is saying, due to the electron accumulation on one side of the conductor along its length, a transverse electric field in the current is produced which opposes the magnetic force on the electron, thereby the accumulation further stop. So when the accumulation further stop, I mean to say that the deflection of charged particle is prevented because of the presence of magnetic and electric field both. That is, we can write an expression like this, that if a charged particle is placed in an electric and magnetic field simultaneously, so a force which is going to act on it is E vector plus V cross B. So if there is no accumulation, then I can say that the F net acting on the particle is 0, and hence I can say that E plus VB is equal to 0, or we can calculate from here that the magnitude of V is equal to E by B. So we can write an expression like this. This expression is also applicable in the concept of velocity separator device. So over here we can use this expression that the magnitude of V is equal to E by B. And now over here we are writing if the electric field E is developed. So we can write it in this way, that the value is going to be equal to the velocity. So the velocity value is I upon NEA. I upon NEA. So the value of electric field that must be developed is calculated as I is equal to IB upon NEA. So this is going to be the value of the transverse electric field that will be created in order to prevent further accumulation of electron. In the next part, the question is asking what will be the potential difference developed across the width of the conductor due to the electron accumulation. So now the question is asking us to find out potential difference. So we can easily do it once we have the value of electric field. So I can write the value of potential difference dV is equal to E dot dr, or the value over here is simply going to be multiplied with d. So we can calculate the value of potential difference simply by using this. V is equal to Ed. So the potential difference will come out to be IBD upon NEA. So this is the required answer for this particular problem.